Hello everyone, my name is Joe Scorso, channel called Ethernet. In today's video, this is episode 21 of the Quant Finance Advent Code, and I changed my mind. I said in the last video with neural networks that we'd be modifying the neural network to be something like an RNN or a deep reinforcement model, but no, we're not going to do that. With how much I would have to do with getting the shapes right and everything, and just how detailed RNNs and CNNs and deep reinforcement models, they're very intricate. I was naive. I thought I could bang them out, add a few more functions, this and that, be on my way. No, not the case. So we're going to do gradient boosting instead. Simpler concept, and way easier to implement because the turnaround on these videos needs to be fast. That's why a lot of them are building on old code, so that way I wouldn't have to make something brand new every video. It's a daily thing, right? So yeah, we're gonna hop right into that. Beforehand, this is my X account. If you guys want updates as soon as everything happens, you guys could find out on here. And this is my algorithm with LuxAlgo. I have a number in my head of how many people I want to have as customers. I'm very close to that. Before the end of the year, I'm very close to it. Check it out. Check it out in the description. You don't have to sign up for it, but I think you should check it out. Of course I do, right? There's more details about it in the description. You guys can read up on all this, and I have videos about it on my YouTube channel. There's a video right here you can watch about it. Yeah, so let's hop into the code now. So actually, well, let's read the task first. So add a gradient boosted NN class. Make predictions based on the residuals of other NNs. Residuals, errors, same concept. We're going to talk about that. Plot actual versus prediction. Cool. So in our code, right, everything besides this class and these lines are identical. Everything else is the same. So now let's see what we're actually doing. Well, we have our gradient boosted neural network. A parameter is the neural network class. We have a number of estimators, our learning rate, and then we fit it with our X train, Y train, and then we just test it. Cool. So let's take a look. So let's take a look at this class. So now we have our base model, number of estimators, and a learning rate. And then we have our models and our alphas. So base model is the neural network class. It's the model that we're trying to gradient boost pretty much. The number of estimators is the amount of times we're going to boost pretty much, I guess. And then our learning rates are learning rate. And then we have a list to store our trained models, a list to store the learning rates of every model. So there's only two functions in this class, which is a fit and a predict. So it shouldn't take us too long to go over this. And I think that the results are awesome for just one more class, two more functions, three more functions technically, because we have an init. So yeah, three. Yeah, regardless, let's get into it. So our residuals are our y.copy at first. It's just an initialization. They do get changed in the loop before we actually do stuff with them. So actually they don't, but they get updated, right? So we have this initialized, then we pretty much have this like first loop through, and then we're just going to go through. I just have to go through it at once because I'm going to stumble over my words. So we're going to initialize the results, right? Because fits, if you take a look down here, has our Y train, right? So that's what we're going to check our X train against to see how right or wrong we are. So yeah, these are our errors. So now we're initializing the errors with the values that we want to predict. So we have our model, and it is going to be a base model. So it's going to be a neural network. We're pretty much just initializing a neural network like we did in the last video. Hidden layer size, output size, number of hidden layers, and input size. Then we're going to train it on X, our residuals, right? Because right at first it's our Y train. Make sure it's the correct shape. This just makes it into a column. And then the amount of epochs, right now it's at 1,000. And then we're going to find out our predictions and then update our residuals. So our residuals is like our error. So we're subtracting it because we want to minimize our error. So we're going to subtract it from our learning rate times predictions, add the model to the list, add the alphas or the learning rates to the list of alphas. We're going to do that over and over and over and over and over again. That is because when we get into predicting for a model in self-down models, our final prediction, we're taking pretty much the average, like a weighted average pretty much. So alpha times whatever alpha we're at times model.predict whatever we're trying to predict off of flatten. That way, we get every single model's prediction in our overall prediction. It's way more dynamic. And this step over here, because remember, after we update our residuals, we retrain it. So it's almost like, here's what the last model got wrong. Fix it. Get it right. And so I'm going to start it running right now, because it takes a while, because we're running 10 of what we did last episode, right? But yeah, just some things I wanted to add is that I just think that it's such a cool idea, because it's not like these are only our errors. Like if we start with our Y train and we subtract this from it, so it's still contextual to where we started. It's just getting more relevant to what the model is actually getting wrong. Something that I want to talk about in the terms of machine learning for finance, and I gotta get past the mental block, I'm just gonna tell you guys, is that machine learning is awesome for stuff like, I'm going to train this network on pictures of dogs so it can predict dogs, right? I'm going to train this network on whatever thing to predict that thing. When the thing is the thing, when the dog is a dog, when the cat's a cat, it's easier, right? Because the only differences that you're going to see, right? I told you this was going to take a while. Because the differences that you're going to see are going to be small. They're going to be small in the sense of it's still a dog, right? In the sense of markets, here we go. In the sense of markets, I'm just going to leave that up and finish my thought. It's way harder because the target's moving. It doesn't always look like a dog. Each uptrend is not like the last. Each downtrend is not like the last. The target is moving. The target is moving, and we need to make sure that we're not wasting our time with the data that we're using. A lot of the data that we have isn't worth using in the context of, why am I trying to predict today's returns based off of returns in 2004, based off of price action in 2004? It doesn't work the same way. It's not the same. It's not right. The market in 2004 is not the same as the market that we have now. I go so far as to say that, because you guys know me, I'd never use backtesting as a form of marketing. Backtests aren't marketing. Backtests are a form of validating market hypothesis. They're not marketing. Of course, if you want to see backtests for the indicator that I sell, I have it on my YouTube channel, because if you ask that, you deserve to know. You do. But they're not marketing. I won't flaunt backtests in front of you and stuff like that. And I think that if someone comes at you with statistics, they're just trying to sell you something right off the bat. I am trying to sell you something, but I'm going to do it differently. Regardless, back to what I was talking about was I'll go so far as to say that a backtest starting at a certain point in time, far back enough, I mean, that whole pocket up to a certain date, it's different for every kind of contextual strategy, is irrelevant. I don't really care what would happen. My biggest look at in something like that, where let's say I'm making a daily strategy, because I've been making a few of them lately, not even just on this, but let's say we're making a daily strategy, and I show you a backtest, and this starts in 2000, right? If the returns are good, they're good. If they're not, they're not. The main thing I would focus on is the drawdown. Not necessarily returns, it's just how straight is the line. How straight is the line when it goes down? Because it will go down, right? Nothing's perfect. But I would go so far as to say that the model up to a certain date is almost irrelevant. The market doesn't work the same as it did in 2000, 2004, right? There's so many differences. From the inception of this country to 2020, $7 trillion were printed. From 2020 to present, about $7 trillion have been printed. That's insane. And we're trying to trade the same way? You simply can't. The liquidity is miles different, and some things are still illiquid. That's just one example of just how some things are fundamentally different to the point where I don't think that people weigh relevance enough when they make models. I don't think that people weigh relevance enough, and I think that people overfit things way too easily. In the sense of they overfit for, if you're going to overfit for something, overfit for drawdown protection, not returns. I would rather, well, it also depends on the person, right? What your appetite is. But from the perspective of me trying to sell you something, right? I'm trying to sell you a strategy, regardless of if I do, regardless of when if I actually have one. I don't want to sell it to you based off of, oh, you're going to make so much money. I'm going to sell it to you based off of, hey, nothing's correct. When this thing's wrong, it's only wrong a little bit. When the other guys are wrong, they're wrong a lot, right? That is how we should build models. That's how we should build things. Don't discount risk. If you're going to do anything, if you're going to model risk in any way, overestimate it, right? Protect yourself. Give yourself every excuse to keep your money. Why would you not? Why would you not? And so it goes into, and now how do we do that? Right now we have little tricks in the way we make models. Now we have gradient boosted networks. Right now we're taking a lot of different models, training them off of how the other ones messed up. And now if you guys watched the last video, now you're here, you would see that this output makes so much more sense than the last one. This output's way more dynamic. Yeah, it took maybe 5 minutes longer, but it looks way more dynamic than it, and it seems a bit more accurate. But obviously, I don't have an actual backtest for it. I don't have like a percentage score of when they're both below and when they're both above, because it's a little irrelevant too. Like, I'm making something right now, and it did this really cool thing that I didn't even notice as I was making it, but sometimes zero line crosses would mark bottoms. It wouldn't mark continuing in an uptrend, which I thought was weird. I'll welcome it. But right, point of the story, there's a lot of little points in everything I just said, but the main point of everything, everything, I suppose, is to get creative, is to break it, right? Is to break it and get it better because you got it. Get it better because your idea got better, not because your parameters got better. A good rule of thumb for if you made a good model is how much do your inputs change the output. I made something the other day. I know I make a million things, but I made something the other day, and I was like, all right, it's all right. It's cool, right? It's working how I think it should. Changed up parameters. Next results were within like 10 percentage points. I was like, okay, I actually have something. That's a great rule of thumb for if you made a good model. When you change the parameters, how much does your output change? It shouldn't change a lot. The less it changes, generally, every situation is different, but the less your models change when you update your parameters, the better. That's why it could be so dangerous to have strategies with look-back periods that are not dynamic. Use a sum of squared errors and get the moving average that best represents the current price. The moving average that's the closest to the current price, and dynamically use that look-back value because it'll change over time. Dynamically use that one. Great rule of thumb. You just won't be overfit. You can't discount how fast and how easily you could overfit some models, right? And so that's why gradient boosting can be so well, because it's, even if one model was overfit, maybe the other 8 weren't, so it gets washed out. Potentially. Ideally. But yeah, I think I'm done monologuing. These are results. Code will be in the repo. And yeah, this was fun. I had a lot of fun making this one. I think my next videos are going to be on gradient boosting, like a random forest. Maybe doing a forest and then gradient boosting a random forest. I just realized that the only one I did was an isolation forest. Maybe I gradient boost an isolation forest. I'm not sure. And then an actual XG boost model, because they're so good. And something about NLP, natural language processing. Haven't even thought about how I'm going to do that. I might use a public article about a specific stock, specific sector, specific kind of commodity, and have the model spit out buy or sell based on the article. Because at the end of the day, that's the question. Doesn't matter how you get there, right? At the end of the day, it doesn't matter if you use a gradient boosted network or if you ask your cat. Bottom line, buy or sell. So yeah, I think that's where we're at. I had a lot of fun making this one. I like yapping. So yeah, I'll catch you guys in the next one, and you guys all have a good day. Goodbye.